Good morning, students. In this video, we are going to look at forces. Learning objective. At this end of this lesson, students should be able to define forces, give examples of forces, and state the three laws of motion. So, what are forces? A force is an influence. Force is an influence that causes an object to change its position and velocity. In simple terms, force is anything that gives motion to objects. For example, speeding up, accelerating, or slowing down. For instance, if I am kicking a ball, the ball is initially at rest. If I am kicking the ball, I need to apply force to the ball for it to travel to a particular distance. So at first the ball was at rest, and when I kick it, the ball travels to a particular distance. So that is an example of a force. Another example could be riding a bicycle. When you are pedaling a cycle, you need to apply force to your legs in order to cycle the bicycle. That is another example of a force because the position is being changing when you are riding the bicycle or kicking the ball. Also, force is a push and a pull factor. Push factor means if I am pushing the table inside the classroom, the table is changing its position, that is a push factor. Pull factor is meaning if I am pulling something towards me, that is a pull factor because it is changing a position, that is an example of a force. Force is a vector quantity. Vector quantity meaning it has a magnitude as in direction, distance or size, and vector quantity also has a direction. For example, if I have a box here and I want to move this box, say 5 meters towards my left. So the magnitude of this box will be 5 meters and direction is towards my left. So that is what a vector quantity. Have you heard about Newton? Sir Isaac Newton? Newton was a person who saw an apple falling from a tree and was inspired to invent a theory of gravity. Newton, he is an English mathematician, expert in mathematics, physicist, and a theologian. In his discoveries, he invented calculus, mathematics, optics, that is white light components, which we will be covering later this term, and three laws of motion. Newton invented three laws: Newton's first law, second law, and third law. He invented three laws, that's why he gave these laws his names: Newton's first law, second law, and his third law. Newton's first law states that an object at rest will remain at rest unless acted upon by an unbalanced force. Also, an object in motion continues in motion unless acted upon by an unbalanced force. Something to note, in Newton's first law, the object continues in motion or remains in rest and have same speed and same direction. For example, if I am rolling a ball from the hill, the ball will continue to roll unless a friction acts on it or I stop the ball. Another example could be if a person is standing over here, and the person will be standing over here if you push him up, and that person will change its position. That is Newton's first law. Newton's second law of motion states that acceleration is produced. The first law was all about external forces. Second law, it gives a relationship between force, mass, and acceleration. Force is measured in newtons. Mass, the SI unit for mass is in kg, and acceleration, SI unit for acceleration is meters per second square. Also, if you are adding more mass, then your force will increase. It means force is directly proportional to mass. Let's do one example to make you understand better. Ranil's car with a mass of 100 kg, the mass is given as 1000 kg, is out of gas. Ranil is trying to push the car to a gas station and he makes the car accelerate at 0.05 meters per second square. The acceleration is given as 0.05 meters per second square. Compute how much force he is applying in the car. So we are given with a mass 1000 kg, acceleration 0.05 meters per second square. We have to find force. So we can use this formula F is equals to ma because we have to find the force, mass and acceleration is given. So just use this formula F is equals to ma, where mass is given as 1000 kg and acceleration is given as 0.05. So press in your calculator, bracket 1000 kg multiplied by 0.05, 50 newtons. So Pranay needs 50 newtons force to push his car. Another example, a 20-gram sparrow flying towards a bird feeder mistakes the pane of glass in a window for an opening and slams into with a force of 2 newtons. What is the bird's acceleration? So now in this question we are given 20-gram mass of the bird and a force of 2 newtons. We have to calculate the acceleration. So now here I can see the mass is given in grams, but the SI unit for mass was in kg. So we have to convert this grams into kilograms. So 20 grams divided by 1000 to give you kg. So 20 divided by 1000 is 0.02. So the mass is now 0.02 kg and then force is 2 newtons. Take this formula F is equals to ma, where force is given as 2 newtons, mass is given as 0.02 kg, and acceleration, we have to find the acceleration. Now 2 is equals to 0.028 divided by 0.02 divided by 0.02, 2 divided by 0.02, 100 meters per second square. The SI unit for acceleration is meters per second square. So the acceleration unit is 100 meters per second square. Next is Newton's third law of motion. Newton's third law of motion states that for every action there is an equal and opposite reaction. For example, if two forces are interacting, the force will apply equal in magnitude and opposite in direction forces. For example, if you are bouncing a ball, the ball will land on the ground and it will bounce back with the same speed and same direction. Another example of Newton's third law is imagine a bird flying. The wings of a bird, when the bird is flying, pushes the air downwards and the air pushes the bird upwards in order to maintain the flight. And the size of the force of air is equal to the force of the bird, as the direction of the bird flying is upwards and the direction of air is downwards. So that is an example of Newton's third law, equal and opposite the reaction. So we have covered Newton's first law, Newton's second law and third law. First law was basically about external forces. Second law, F is equals to ma, the relationship between force, mass and acceleration. Third law was about action and reaction forces. Now resultant forces. What is a resultant force? A resultant force is when two or more forces is being applied to the same object and that can be replaced by a single force. For example, if I have an object over here and a force of 20 newtons acts upwards and a force of 60 newtons is acting downwards. So we can manipulate these two forces into one. That is a resultant force. Also, to calculate the resultant force, we have to add all the forces acting on one object. For example, this one, 20 newtons acting upwards and 60 newtons force acting downwards. So adding two forces, 20 newtons with the direction, 20 newtons upwards plus 60 newtons downwards. So we cannot add these two values because the direction is in the opposite direction. So in order to solve this, we can see that 20 newtons is greater in mass than the 16 newtons. So 20 newtons upwards, change this direction downwards into upwards. And when we do that, this positive will change into minus. Now we can see that the direction is in the same direction. So to just subtract it directly, 20 minus 16 is 4. So the resultant force is 4 newtons in this direction, upwards. That is a resultant force. Another example is if I have a triangle with 8 newtons acting towards this side and 6 newtons upwards. Now this one force is acting upwards and one force is acting this side. So we cannot add this directly. So to solve this, we have to use the Pythagoras theorem. So what is the Pythagoras theorem? C squared is equals to A squared plus B squared. Your C will be the longest length, the hypotenuse one. This is your C. Your A is either this side and B is either this side, whichever you wish. So in this case, we have to find this one, our resultant force. Our A, let's say 8 newtons is our A and 6 newton is our B. So A squared is A squared plus B squared is 6 squared. Now 8 squared plus 6 squared. Now your C is equals to 10 newtons and the direction is this side. Okay, so let us conclude our lesson. Our aim was to define forces, give examples of forces and state the 3 laws of motion. So we have already covered them. What was force? Force is anything that causes motion of objects, that is to change its position and velocity. Some examples we covered, that was kicking a ball and pedaling a cycle, pushing a furniture, and the push and pull effect that we covered. And the 3 laws of motion. Newton's first law of motion was an object at rest will remain at rest unless and until acted upon by an unbalanced force. Also, an object in motion continues in motion with the same direction and same speed unless acted upon by an external force or an unbalanced force. That was Newton's first law of motion. Newton's second law of motion was acceleration is produced when force acts on a mass. F is equal to ma, where F is the force measured in newtons, mass measured in kg, and acceleration is measured in meters per second squared. That was Newton's second law. And Newton's third law of motion was that for every action there is an equal and opposite reaction. An example we did was bouncing a ball, and the ball bounces off back with the same speed and same direction. That was Newton's third law of motion. So that was all for today. I hope you liked the video.